Section 8.3 is on special right triangles. Consider a square. All four sides are congruent and all four angles are congruent. They're all 90-degree or right angles. Now, when we draw a diagonal, because the diagonal of a square bisects opposite angles, we have two 45-degree angles in each corner. So what was once a 90-degree angle is now 45. And what we have here is what we call a 45-45-90 right triangle. One of these triangles created by drawing the diagonal has two 45-degree angles and a 90-degree angle. As I said, we call this a 45-45-90 right triangle. Its legs are congruent, so I'm going to call those x, but what we need to do is find out the length of the hypotenuse. Because this is a right triangle, I can use the Pythagorean Theorem. Remember, the Pythagorean Theorem says leg squared plus leg squared equals hypotenuse squared. So one leg is x, as is the other leg, and in this case I've decided to call the hypotenuse for now c. So that gives me x squared plus x squared equals c squared. X squared plus x squared is 2x squared. And what I'd like to do is to get rid of the square on both sides. So I'm going to take the square root of each side. So the square root of 2x squared is the square root of 2 times the square root of x squared. The square root of x squared is just x, and the square root of 2 can't be simplified any further, so we leave it like that. And the square root of c squared is just c. So the length of this hypotenuse is whatever x is times the square root of 2. The length of a leg times the square root of 2. Therefore, the hypotenuse is the length of the leg times the square root of 2. And this is going to be true for every 45-45-90 right triangle. Whatever the leg is, the hypotenuse, or the longest side, is leg times the square root of 2. Here's how I like to remember it in a little formula form. Hypotenuse equals leg times the square root of 2. Let's use that in an example here. Here we have a triangle, a right triangle, and because these two sides are congruent, I know that it's an isosceles triangle, and by the isosceles triangle theorem, if the two sides are congruent, then the two angles opposite those sides are congruent. Since this is a right angle, and these two are congruent, these two are each going to be 45-degree angles, and so I have a 45-45-90 right triangle. This is a leg, this is a leg, and this here is my hypotenuse. So what I need to find is the length of the hypotenuse. So I'm going to use my little formula that we developed on the previous page. The hypotenuse is equal to the leg times the square root of 2, and I'm going to plug in what I know and what I don't know. The hypotenuse is x, the length of the leg is 5 times the square root of 2. So x is equal to 5 times the square root of 2. Here we have another 45-45-90 right triangle, and I know that because these two angles are congruent, and it's a right triangle, so those must be each must be half of 90. Here I have my leg. I have another leg over here, which I know also has to equal x, and 6 is my hypotenuse. So again, now I have to find the length of the leg. I'm going to use my formula. Hypotenuse equals leg times the square root of 2. I'm going to plug in what I know and what I don't know. My hypotenuse is 6, my leg is x, and I have a square root of 2. Now I have to solve this equation for x. So I'm going to divide both sides by the square root of 2. These cancel out, and leave me with x equals 6 over the square root of 2. Now, if you remember from algebra, we cannot have a radical in the denominator. We can't have a square root in the denominator of a fraction. So I need to rationalize my denominator by multiplying the top and bottom by the square root of 2. Multiplying across the top, that gives me a 6 square root of 2. Square root of 2 times the square root of 2 is just a 2. And again, I can cancel a little bit further. I can cancel the stuff that's outside the radical. That gives me a 3. So my final answer is x equals 3 times the square root of 2. And that's the length of the leg of this right triangle. Next, let's consider an equilateral triangle. Remember, an equilateral triangle has all 3 sides congruent and all 3 angles are congruent. They're all 60-degree angles. So this here is a 60, and this one's a 60, and then ignore the altitude for now. The big angle at the top is also a 60. When we draw this altitude, remember an altitude goes from a vertex perpendicular to the opposite side. It bisects the top angle and the bottom side. So these now become 30-degree angles up at the top here. And these 2 segments on the bottom are going to be congruent to each other. So what we have is 2 30, 60, 90 right triangles. That's what we get when we bisect, or when we draw an altitude and bisect the top angle and the base of the triangle. So drawing just one of those, okay, the hypotenuse of this right triangle is one side of the equilateral triangle. The shorter side of this triangle, the one that's opposite the 30-degree angle, is 1/2 of the side of the equilateral triangle. So let's go back and take a look at this over here. Just to make it a little bit easier, if I were to call this side 2x and this side 2x and this whole side here 2x, then when I draw this altitude, it actually turns each of those little pieces into an x. And you can do this with just an x on the side of the triangle, but then you're going to end up with fractions down here. So if I call one whole side of the triangle 2x, I end up with not a fraction, which is going to be a little bit easier to deal with. So going back to our 30, 60, 90, I have a short leg that's x, the hypotenuse, which is 2x, and remember this longer leg here, this was my altitude. Maybe I'm going to go ahead and label those. So this is my short leg, this is my long leg, and this is my hypotenuse. But I need to figure out an expression for the length of this longer leg, the altitude of the large triangle, in terms of x. So again, we're going to use the Pythagorean Theorem. My hypotenuse is 2x. So I'll have a squared plus x squared, those are my 2 legs, equals 2x squared. Or a squared plus x squared equals 2x squared. Remember that means 2x times 2x, which is actually 4x squared. Solving this for a, I'll subtract x squared from both sides. So 4x squared minus x squared is 3x squared. And taking the square root of each side, a is equal to square root of 3. I have to leave that as square root of 3. Square root of x squared is x. So the length of that altitude is whatever the short leg is, which is x, times the square root of 3. So let's come up, so this is the length of the long leg. A little arrow over there. Okay, so let's come up with some formulas for this. So notice that the hypotenuse is 2 times the length of the short leg. Whatever the short leg is, in this case it's x, the hypotenuse is double that. Okay, and my long leg, which I was designated by a, my long leg is equal to the short leg, which is x, times the square root of 3. So given these two little formulas here, given any one length of any one side of a 30, 60, 90 right triangle, I can find the lengths of the other two sides. The hypotenuse is twice as long as the short leg, and the long leg is equal to whatever the short leg is times the square root of 3. Let's take a look at some examples here. So in this triangle, I have a 30, 60, 90, and I know that's the case because this is 60 and that's 90, so this one has to be 30. And this is my short leg because it's opposite the 30. This is my long leg, and this is my hypotenuse because it's opposite the 90-degree angle. So what I know is my short leg. So let's use a couple of those little formulas. I know that the hypotenuse is equal to 2 times the short leg. And I know that the long leg is equal to the short leg times the square root of 3. So my hypotenuse is y. My short leg is 7. So y is equal to 14. My long leg is x. My short leg is 7 times the square root of 3. So using these two little formulas, given the short leg, it's very easy to find the length of the hypotenuse, which was y, and the length of the long leg, which was x. Here's another 30, 60, 90 right triangle. And here I have my short leg is x, my long leg is y, and my hypotenuse is 12. So I'm going to go ahead and write my two little formulas. Hypotenuse equals 2 times the short leg, and long leg equals short leg times the square root of 3. Now, the only number that I know is the hypotenuse. I don't know the short leg, I don't know the long leg, I only know the hypotenuse, so I have to use that formula first. So let's put in 12 for the hypotenuse, 2, and I'm going to put in x for the short leg, dividing both sides by 2. X is equal to 6. So my short leg is 6. Now I can use my other formula. I don't know what my long leg is, so that's called y. My short leg I found was 6 and a square root of 3. So the value for y is 6 square root of 3. And let's do one more example, and this one's the most difficult one. Oh wait, I do have one more page after this. Okay, again we have a 30, 60, 90 right triangle. And I'm going to go ahead and label my short leg, which is opposite the 30, my long leg, which is opposite the 60, and my hypotenuse, which is opposite the 90-degree angle. I'm going to write my two formulas. Hypotenuse equals 2 times the short leg. Long leg equals short leg square root of 3. Now, the only number I don't have a number for the short leg. I don't have a number for the hypotenuse. I do have a number for the long leg. So I'm going to have to start with this second formula over here. Because I have nothing. I don't know the hypotenuse. I don't know the short leg. I can't use that one at all. So long leg is 9. Short leg is x. Square root of 3. Let's solve that for x. Divide both sides by the square root of 3. So x is equal to, those cancel out, 9 over the square root of 3. Again, I can't have a radical in the denominator, so I need to rationalize my denominator by multiplying by square root of 3 over 3. That gives me 9 square root of 3 over 3. And those can cancel. So x is equal to 3 square root of 3. So x was the length of my short leg. So now I can use the other formula. I don't know my hypotenuse. That's called y. 2 times, and my short leg is 3 square root of 3. I can multiply the numbers out front. Y is equal to 6 square root of 3. So 30, 60, 90s are a little more complicated. There's two formulas, and I think we did an example of each one, each possible each possible triangle that you can do, one where you're given the short leg, one where you're given the hypotenuse, and one where you're given the long leg. Really important, memorize these little formulas. For a 45, 45, 90, there's one formula. The hypotenuse is equal to the leg times the square root of 2. For 30, 60, 90, there are two formulas. Hypotenuse equals 2 times the short leg, and long leg equals the short leg times the square root of 3.